Okay, here's a good kind of beginner example for doing relative motion. This will be, I think, pretty easy. But here we have a guy who's on a train, all right, and he's climbing up the train. He's climbing vertically up a ladder on the train. So he's moving with respect to the train. But it's also true that the train itself is moving with respect to the ground. And so, let's say you're a person on the ground, or you're in the ground's frame of reference right here. What are you going to see when you look over here at your buddy climbing the train? He's climbing up, all right, but the train is moving over towards the right, and so you're going to see your friend move up in a direction like that. So that's what we're going to try to figure out with this problem right here. Okay? So let's make sure we write down our vectors and put them with the correct subscripts so that we can accurately add them together. Okay? So the velocity of the person to the train is what? That's 3 meters per second. All right, now he's moving straight up. Okay, so that's at 90 degrees. You could say north of east, or sometimes we just say 90 degrees north, right, because it's straight up. All right, that's the velocity of the person with respect to the train. All right, and the train itself, I did that one in blue. The velocity of the train to the ground is, come on now, 5 meters per second at 0 degrees north of east, right? Because the train is moving due east right there. So if we want to find out what the person on the ground is viewing, oops, let's erase that there. What's the person on the ground seeing? Somebody from the point of view of the ground. Well, we want to find the velocity of the person with respect to the ground. That's what we want to find out. Okay, it's a question mark right there, not a 2. All right, so let's see first of all, do we have our vectors in the right order? Can we add these up together? Can we say velocity of object 1 to object 2 plus the velocity of object 2 to object 3 equals the velocity of 1 with the velocity to object 3? And the answer is yes, we can. Everything is in the right order. And there may come a time that we need to flip some of these around so that the subscripts are in the right order, but they're in the right order already. That's object 1, that's object 2, 2 and 3, and that's 1 and 3 right there. So now let's just add them up. Okay, so we have a let's add our vectors together using a chart. Okay, you could put them in actually unit vector notation too if you wanted to. In fact, let's just go ahead and do that. Let's write the person climbing the train, the velocity of the, oops, wrong color, velocity of the person with respect to the train. Let's do that in unit vector notation. This will make it actually kind of easy. All right, that is 0 degrees, or that's 0 meters per second in the x hat direction, right? He's not moving in the x at all, but he is moving at 3 meters per second in the y hat direction. All right, and the velocity of the train with respect to the ground, now that's 5 meters per second in the x hat direction and no meters per second in the y hat direction. So if we add them up, the velocity of the person to the ground is, well, 0 plus 5, that's easy, 5 meters per second x hat and 3 meters per second y hat. But we kind of already stated that, didn't we? We kind of said that, all right, well, he's going to be moving over and he's going to be moving up as well. Well, the question then is, well, how do we figure out what that velocity and direction is right there? Well, we can find the magnitude of this because we have the x hat and the y hat direction. So we'll say the magnitude of the velocity of the person to the ground is going to be the square root of 5 squared plus 3 squared. That's how we get our magnitude. That's our modified Pythagorean theorem, right? 5 squared plus 3 squared. There's my calculator right there. So 5 squared is 25, plus 3 squared is 9, right? That looks like 34. So square root of 34. Oh, come on now. Square root of 34 is 5.8 meters per second. All right, 5.8 or 83 meters per second. At what angle right here? Well, the angle of the vector of the velocity of the person to the ground is going to be the inverse tangent of what over what? It's going to be the y over the x, right? The 3 over the 5. So the inverse tangent of 3 over 5, I get 30.9, I'll say 31 degrees. 31 degrees what? Well, that's north of east right there, right? 31 degrees north of east. So your final answer is going to be the velocity of the person to the ground is going to be 5.8 meters per second at 31 degrees north of east. We wrote it a while ago in unit vector notation, and this right here is magnitude and direction notation. So that's example 4.5, number 1. This is the beginning of our adding of vectors so that we can determine relative motion. See in example 2 in just a bit.